solving trig equations. Last unit we were verifying or proving trig equations and with using all those identities, but now we're going to actually be solving for a variable that makes the equation true. So the first blank we want to fill in here is to solve the trig function, your goal is to isolate sorry if my handwriting is not great. My tablet thing I usually use is not working, so I'm having to do this with a different tool, and it's not as precise. Okay, and FCN, that's my abbreviation for function. So isolate the trig function. Sorry, it's being very difficult to move. Okay, so the first thing we want to recall are our three trig graphs. So it's been a while since we graphed, so remember the sine cycle. If we look at a single cycle from 0 to 2 pi, it starts at the origin, goes up to 1, back through 0, down to -1, and back to 0 once you get to the angle 2 pi. So that's one trip around the unit circle, one revolution. Okay, and for cosine, cosine starts high and ends high, one cycle from 0 to 2 pi. And then remember tangent, it's the one that had the different period. Okay, so in both sine and cosine, one cycle to complete it, it took, that's supposed to be a p, the period was 2 pi. Oh gosh, this is going to be rough. It's a little better. Okay, but for tangent, it was different because remember, tangent is sine divided by cosine. So anywhere that cosine was 0, which was here and here, tangent was undefined because you can't divide by 0. So that's why there's asymptotes here and here. Okay, so it looked slightly different, and it didn't take as long for the function to start repeating itself because between all of those asymptotes, it was the exact same curve over and over and over. So between asymptotes, your period was 1 pi. Okay, so at a shorter period. All right, so in this little paragraph down here, it says, remember the period, the number of radians to complete one cycle for sine and cosine is 2 pi. And for tangent, it was only 1 pi. If we're talking in degrees, remember, that'd be 360 degrees versus 180 degrees. Okay, so once you isolate the trig function, we're going to give our solutions or our answers within that period, within that window, within one cycle of the function. Okay, so our answers for sine and cosine can be from 0 to 2 pi, and our answers for tangent can be from 0 to pi. But notice this down here, brackets, and then on both, because it can be anywhere from 0 to pi, we can include any of those. But on sine and cosine, there's only brackets on the 0 because 0 and 2 pi are the same location. If you included both of those, it would be repetitive. So that's why we're not going to include the 2 pi. So it's a parenthesis on 2 pi. So keep that in mind. All right, so when we look at this first example, we want to isolate the trig function. So 2 is being multiplied by sine of x, so I'm going to divide by 2. 2 to one side, 2 to the other. It's like solving an equation. Okay, so we get sine of x is equal to 1/2. So now you're to the point where you're asking yourself, okay, sine at what angle is 1/2? So I've drawn a little coordinate grid for us here to think about. One, this answer is positive. That's positive 1/2. So first we are going to narrow down our answers to where sine is positive, which is quadrants 1 and 2. So we know our solutions are not coming from these quadrants. And then you need to think back and remember those common reference angles you learned. Sine, remember it corresponds to the y value on the unit circle, is 1/2 at a 30-degree reference angle, okay, but in both quadrants. So here and here. Okay, now if we're talking in degrees, we just said that would be 30 degrees for the quadrant 1 angle. And if you're 30 degrees from 180, that means you're at 150 degrees in quadrant 2. Okay, we are going to give our answers in radians for this. Okay, so if you want to make a note of what we're thinking, the process, so you have this to look back on in your notes. Okay, so the first thing we did was say that sine is positive in quadrants 1 and 2. Okay, so that was the first thing we determined in the problem. Now the next thing we did was figure out the question was asking at what angle is sine's value 1/2. Okay, so we are going to convert our answers 30 and 150. We're going to put those answers in radians. So 30 degrees, that is your pi/6 radian angle, and 150 would be your 5 pi/6 radian angle. So you have two solutions to this problem. All right, in the second example, we're going to start out the same way, isolate the trig function. So the first thing I'm going to do is add the 1 over. So then I've got 3 tan squared of x is equal to 1. It's supposed to be a squared there. Try and fix that. Okay, so then the next thing I'm going to do is get rid of the coefficient of 3. So then I've got tan squared of x is equal to 1/3. Now, I haven't isolated it yet. It's still being squared. I want to get tangent of x by itself completely. So the opposite of square is to square root. Now, remember, when you take the square root in the process of solving an equation, you always have to put that plus or minus in front of the square root. So the square and square root cancel each other out. So we have tangent, it's an n, equals the positive or negative square root of 1/3. But here's the thing, when you take the square root of a fraction, you're taking the square root of the numerator and the denominator. So we have the square root of 1 is just 1, and then over the square root of 3. Now, that is not a perfect square, but we don't leave radicals in the denominator, so now we got to rationalize. So when we rationalize, we multiply by the radical in the denominator we're trying to get rid of. So then my denominator is just 3, and the numerator is square root of 3. And that plus or minus is still there. Okay, now we're going to figure out what quadrant we're in though. It says positive or negative. So tangent's positive and negative in all the quadrants. So it's not reducing any quadrants. But we think back to what we just said on the first page of the notes, and we said that tangent, the period is 0 to pi. It's shorter. So we're only going to give solutions from 0 to pi. So we are still only going to give solutions in this highlighted section, just based on the fact that it's tangent. Okay, it's not based on the fact of the positive or negative. That didn't reduce anything. It's the fact that it's tangent. Okay, so we're going to give answers in quadrants 1 and 2. here, if you want to make a note of that, the reason we're limiting to those two quadrants, we are only giving solutions from 0 to pi. Oh, let me undo that. There we go. Okay, so that's why we reduced it to that two quadrants. Okay, so then we think back to our unit circle, and if y'all still have your unit circle from your notes, bust it out and use it. Pull one up online. I'm sure you can find a completed unit circle. It's back in my notes. If you're in my class, it's still on its learning. All right, so where is tangent square root of 3 over 3? Remember the memory trick I told you for that extra 3? Because remember there's square root of 3 and square root of 3 over 3 as two of the tangent values. And that extra 3 is at 30. Because remember 30 starts with 3 and has the extra 3. Okay, so this is happening at a 30-degree reference angle. And we just said in the last problem, a 30-degree reference angle over here is 150. So we are again, though, going to give those answers as radians. So we actually end up with the same answers at pi 6 and at 5 pi 6.